another interesting video. In this one, we are going to look at this problem which says 3 sum with multiplicity. It is on lead code, it is of medium complexity. And the description says given an integer array R and an integer target, return the number of tuples I, j, k such that I is less than j, it is less than j is less than k. And the sum of elements at these indices matches up to target. As the answer can be very large because there could be so many tuples combinations, and that is why there is this condition where we should return it as modulus of this number. So this is the problem. This is different than the other 3 sum problems, and it's a very interesting one because it needs quite a bit of thinking to come up with a solution which has linear time complexity. Let's go through the examples real quick. So for an array like this, if the target is 8, the expected output is 20. And why we are expecting 20 as an output? So 1, 2 and 5, these elements are available at different indices, and there are 8 such combinations. So such a tuple of elements is like counted 8 times because I, j and k are different for those combinations. For example, this one and j at index 2 and k at index last is one combination, and then 1, 2 and the second last k is another combination. So that is how there are like 8 such combinations of 1, 2 and 5 at different indices, which matches up to the total of target. Similarly, 1, 3 and 4 are also counted as 8 times their indices, and 2 to 4 this element tuple is appearing twice because they have different indices. So and 2, 3, 3 again is counted as twice. So that is how the sum is 20. Explaining it with a simple example where the number of elements are not very high is rather easy. So in this case, if target is 8, then what do you have? So you have this I at this position, j at this position, and then k at this position. This is one tuple. Then 1 at this position, 2 at this position, and 2 at this position. This is a second tuple. And then 1 at this position, 2 at this position, and this at this is third, and so on and so forth. So basically there are 4 plus 4 such combinations, 4 and 4, 8, for another 4 for this one. So that's what all this problem is. Now let me go through a brute force solution for this, which is based on how we solve the 2 sum problem, and that video is also available on my channel. Let me first write up the code, and then we can discuss the intuition, etc. Mod so now we want one loop that starts from the 0 index all the way to the length of array, and then within this we are going to create a hash map. And then we are going to calculate rem.target is equal to target minus array. And then we need another loop which is starting from the next index from I and all the way up to array.length j++ In this one, what are we going to do? We are going to check if the object contains rem target minus arr of j, and if it contains, then that means that we have to update the counter. Now is the right time to talk about the intuition of this program. So so how we are solving this is that and we will go with our example 1 1 2 2 and 5 and 5, and let's have our map. So this is our map, which is null when we are at the first iteration of the output loop, and with every increment in the loop we are anyways creating a new map. So we'll look at first iteration. So first iteration, rem target is let's just write rem is 8 minus 1, which is 7, and then we are looking at map dot contains key 7 minus 1. So this is where we are actually checking that if there is a tuple which if we add up their element, it becomes the target. So because this is how we are finding the remaining from subtracting the element at the inner loop outer loop with the target. So 8 minus 1 7. Now if we find an element which is the remainder of remaining target minus the inner loop element, let me just write in a loop as well, then that means we have found the tuple. Now in this case there is nothing, we don't have any 6, and then again we are looking at 7 minus 2, we don't have it. But when we don't find any key, or we find it or we don't, we are going to add into the map. So 1 is added, key is added as 1, and the value is 1. So it tells that the value is like the occurrences, number of occurrences of a given element. In this case 1 is 1. 7 2, we add 2, and the occurrence is 1. We again find 7 minus 2. We don't have 5 in the map so far, but we will increment the value of key 2 by 1. Now we are at element 5, and we are looking at 7 minus 5. Here we're going to add counter is equal to the map dot get. So earlier counter plus counter map dot get 7 minus 5, and that is 2. So counter would become 2. Then the next element is also 5. So we are going to again increment the counter with 2 plus 2, 4. So this is what we are doing in the first iteration. And in the second iteration also the same story goes, because we are not going to like keep the map growing. We will create a new map, and this time around the map would start with 7 minus 2. So our counter is already 4 at this point, so counter would become 6, and then 6 plus 2, counter would become 8, and that's our answer. So that's the intuition. Now let's turn it into program. My counter plus objmap dot get rem target minus arr of j, and then I think we also also have to do modulus because we do not want this number to go above something which leads into overflow. And then we are going to add the key rj, and value is objmap.get or default rj 0 plus 1. So that's, let's just remove the comments here. So that should be good enough. Now let's just return the value of counter and run our test. Okay, can I initialize? Perfect, so it works. Let's just try submitting it. So it works, but we see a very high runtime. Let me try in a couple of times. So yeah, it is in the order of 2300 milliseconds, so over 2 seconds, which is pretty bad. And the one reason for that is that obviously the time complexity here is O(n) square, so it's not a fast solution by any means. And then somewhere the obj map that also has a initial capacity limit of 16 with a default load factor of 75%. So some of that resizing is also adding into this time latency.